Hey everyone, welcome back. In this video we're going to start something that's a little bit more complicated than what we've been doing so far. So what we've been doing so far is just working through a few problems that involved a single variable, which we've been commonly labeling as x. But all we've had is some sort of equation, like I've just sort of thrown something like 4x plus 4 is equal to 20 or something like that, and then I've just asked you to solve for x, which isn't really that hard, or at least hopefully you'll agree with me that it's not that hard. But what we're going to do in this one is we're going to slightly increase the complexity, not by actually making the math harder, but by making you sort of work to create the equation. So basically, what we're starting in this one is I'm going to give you the question as a word problem, and we're going to have to extract some of the information. All right, so we're going to have to extract the useful information from the question and then use that to generate an equation like this one, to build our equation, and then we'll use that equation to actually solve it, to actually solve for x. All right, so you could title this one word problems or word problems with a single variable. So let's see, word problems. I'll just call it word problems just to sort of save us some time. And there's going to be a little bit of writing in this one. I'm going to write out the question on the board first, and then we'll extract some of the useful information, and we'll rewrite just that useful information. Now, obviously, you guys don't have to rewrite anything. I'm just going to have sort of limited space, so if I'm writing out the entire question here, then I'm going to run out of space really fast. So we'll start with, we'll do three different questions. So we'll start with question one, which is going to be the following. So Arnold buys 14 apples and 3 oranges from a grocery store, let's say. I'm not going to say the grocery store part, but Arnold buys 14 apples and 3 oranges. We know that an orange is going to cost twice as much as an apple. Twice as much as an apple. If the, that's an if right there, if the total cost of the apples and the oranges, if the total cost is $40, find the cost of one apple. So, that's the question. That's the task at hand. So, Arnold buys 14 apples and 3 oranges at a grocery store, let's say. An orange costs twice as much as an apple. If the total cost is $40, find the cost of one apple. Now, some people tend to prefer to physically write stuff on the question, so like they'll have a highlighter or they'll use a pen or a pencil to underline useful information in the question. For me, I never really felt the need to do that, but you're more than welcome to do that, and what we'll do when we're working through these is I will underline or circle or something the useful information in the problem. So, what do we know? We know that Arnold is buying 14 apples. This is useful. So we've got 14 apples. We've got 3 oranges. I'm going to sort of do it like a continuous, it wraps around there. So we've got 14 apples and 3 oranges. That's what we know. We know an orange costs twice as much as an apple, right? We know it costs twice as much as an apple, and we know the total cost is $40, right? Those are the sort of key things. So if I erase basically what we don't need, let me just, for the sake of my own space, you don't have to scratch anything out or erase anything. Pause this if you haven't had enough time to finish writing down the problem yet. But I'm just going to erase all the stuff that's not important. We don't care that this person's name is Arnold. We don't care about... Oh, I mean, we just don't... I'm just basically erasing these little words here and there. Everything else is pretty important. We basically just don't care about the name. I'm just going to make a note here that this $40 is the total, so that we have that information. And we want to find the cost of one apple. So we want to know one apple is how much. Alright, so the way we would solve this is, the first thing we want to do is, if we're going to be using a variable, we need to write what's called a let statement. So a let statement is, it's always going to start with the word let, L-E-T, and you choose what you're going to call your variable. So since we've been using x, I'm going to use x, but you could use whatever you want. You could use a different letter, you could do maybe A for apple, something like that. But then you have to say what this variable represents, because if the variable hasn't been given to you in the question, you can't just magically create the variable and expect people to know what it stands for. So we have to state what it stands for. So I'm going to say let x equal, or you could say let x be the cost of one apple. Cost of one apple. Alright, hopefully by this point you've copied all of the useful information, this 14 apples and 3 oranges business, so I'm going to get rid of it from here. I wrote this stuff down on paper so that I don't lose any of that important information when we're actually working through the problem. So we want to know the cost of one apple, right? So we started with our let statement. Let x equal the cost of one apple. That's what the question has asked us to find, right? So we want to basically solve for x, but the problem is we don't have an equation to solve for x yet. So we need to make an equation using the other information that we got in the question. So if the x is the cost of one apple, we know we're buying 14 apples and 3 oranges, right? So we know we're buying 14 apples and 3 oranges. It's just a little note for us to return to later. So then you don't really have to do it this way, but I sort of advise you to do it this way, is after you write your let statement where you're telling people what the variable actually represents, then follow up with a sentence that begins with the word then, and sort of write down something that's useful for solving the problem, preferably using something from your let statement. So for example, if we know x is the cost of one apple, then that means 14 apples will cost 14 times x dollars, however many dollars x ends up being equal to. So this is going to help us solve, I'm going to actually make that a comma because we're going to add to this in a sec. So this is going to help us solve the problem, because now we've got an expression using numbers and variables to determine the cost of the 14 apples, right? That's not what we need for the problem. We want to know what the cost of one apple is, but if we could find the cost of 14 apples, then we could find the cost of one based on that. But we also know that, I'm not going to put and yet, so we know 14 apples is going to cost 14x, whatever x is equal to. We'll just multiply it by 14 for that. Now, we also know that one orange costs twice as much as an apple. So if the cost of one apple is going to be x, then that means the cost of an orange is going to be double that, or 2x, right? 2 times x. So what we've got now is we know how much the 14 apples is going to cost in total, and we know how much the one orange is going to be as well. So we know 14x is for all 14 apples, but we didn't get one orange, we got 3 oranges. So so we get that 3 oranges will cost, so 3 oranges is going to end up costing us 3 times the cost of the price of 1 orange, right? So 1 orange is going to be 2x, so 3 oranges is going to be 3 times that, or 6x, right? Hopefully that's making sense. We've got x is the cost of 1 apple, so that means if x is the cost of 1 apple, then 14x is going to be the cost of 14 apples, and since 1 orange is double an apple, so since the price of an orange is double that of an apple, we know that 1 orange is going to cost 2x, where x is the price of an apple, so that means 3 oranges is going to be 3 times bigger than that, or 6x. Now the last piece of information that we have is that the total cost is $40. So that means the total cost is the sum of the cost of the 14 apples, so this bit right here, and the cost of the 3 oranges, which is this bit down here, right? We bought 14 apples and 3 oranges in total, so we get that $40 is equal to, well, the price of the 14 apples is 14x, and the price of the 3 oranges is 6x. Right? So, if I can combine these two together. It's just 14x plus 6x, so that's going to be, if I add those together, I'm going to get 20x. So we've got 40 is equal to 20 times x, and now I'm just going to erase this top part right here, just so we have enough room to finish the problem. You can probably see what the answer is at this point, but we don't want, maybe I didn't need to erase that, we don't want 20 times x, we want just x, so I'm going to divide this side by 20, and I'm going to divide this side by 20, and so on the right side, the 20 and the 20 will disappear, and I'll be left with just an x. Yeah, I'll throw it up here. I'll be left with just an x, that's on the right side, and on the left side I've got 40 divided by 20, which is 2. So if you weren't seeing that before, we got 40 is equal to 20x, so x has to be equal to 2 in order for that statement to be true. 20 times 2 is going to equal 40. So now we've figured out what x is. We just need to go back and remind ourselves, I've erased it now, but from our let statement, we know that x is the price of 1 apple. It's how much 1 apple is going to cost. So the last thing you should do is write a therefore statement. And so this symbol here, let me make that a little bit larger, with those 3 dots like that, means therefore. Therefore. That's what that means. And so you'll finish off your question, or your answer to the question, with a therefore statement. So you'll put those 3 dots, and then you'll actually answer in words what the question was asking. It asked us to find the cost of 1 apple, so we'll say 1 apple costs $2. Alright, now the one thing that we could have improved upon in our let statement, I sort of let it slide for this first one because I didn't want to throw too much information at you all at once for our first word problem, but the best way to write our let statement, so if I go back to the let statement that we wrote, if we go back to that let statement, we'd written something like let x be, or let x equal the cost of 1 apple, right? That's what our let statement looked like, was let x be the cost of 1 apple. Now that's fine if you are only dealing with dollars throughout the question, then you should be fine, but it would be a little bit better to say let x be the cost of 1 apple in dollars, because when you're working through the problem and you get x equals 2, we don't know if we've sort of lost the meaning of what x actually stands for when we're working through the problem. We don't know if x means dollars, cents, pesos, oranges, apples. If you confuse yourself, then you won't know to what was x supposed to be equal to. So that's why it's important to write a let statement so you know what your variable actually stands for. But then if you say in dollars, if you include the unit of measurement, if you're measuring length, then you should say in meters or in centimeters or in inches, whatever. If you're doing something to do with money, you should specify in dollars, in cents, in pesos, whatever we're working with, and then use that in your answer, because we just had x equals 2, and then in our therefore statement we threw a dollar sign in, which you might not have done if you didn't remember to put something like in dollars in your let statement. Okay, so hopefully that's making sense. That's basically the way we work through it. You take out the important information from the problem, and then we'll write a let statement sort of based on what we're trying to find. We'll build an equation out of the important stuff, we'll solve for it, and then have some sort of concluding statement. So we'll do at least one more, and then time permitting, maybe one quick one after that as well. So the next one is going to be problem number 2 of the day. So, problem number 2. This one is John and Jessica. I'm just going to write Jess for short. John and Jess are writing a math test. John and Jess are writing a math test. John's score on the test is 6 marks. Is 6 marks higher than Jessica's. So John does better by 6 points on the test. So John's score is 6 marks higher than Jess's. And the sum of their marks is 110 in total. So if the test is out of, like, I don't know, 60 or 70 points or something, then if you added John's score and Jessica's score together, you'd end up with 110 points. And what we want to find is each of their test scores. So find John and Jessica's test scores. So find each of their test scores. Alright, so I went ahead and solved this one a little bit earlier, so I'm gonna leave this up for now. Pause the video here if you need to finish copying down the problem. I'll read it out one more time so that you can catch any words that perhaps you can't read with my writing here, and then I'm gonna erase it, and we'll put our let statement and get our equation on the board. So we have John and Jess are writing a math test. John's score is 6 marks higher than Jess's, and the sum of their marks is 110. Find each of their test scores. Alright, so pause that if you need to copy it out, but I'm going to get rid of that here. Now, for our let statement, you could say let x be John's score and let y be Jessica's score. You could use 2 variables, but we haven't really worked with 2 variables yet, so I'm going to do it a slightly different way. And what I'm going to do is, because we talked about John's score in relation to Jessica's, we said John's score was this many marks better than Jessica's, I'm going to make my let statement based on Jessica's test, and then we can find John's test score based on that. So you could do it the other way. That would be just fine, to make your variable something about John's test and then find Jessica's from that. But I'm going to do it this way. So let x represent or equal Jess's test score. So let x equal Jess's test score. So now we know if we solve for x, we're going to ultimately get Jess's test score out of this, which is great. The problem does want us to solve for Jess's test score, but we also want to find John's. So I'm going to put a then statement just below this. So then x plus 6 equals John's score, John's test score, right? And now it's x plus 6 because we know from the problem, if you go back and read it, we said John's score is 6 marks higher than Jessica's. So x is Jessica's score, and John's is 6 higher, so we have to add 6 to Jessica's score to get John's score here. Alright, so x plus 6 is going to be John's score, and x is going to be Jessica's score. Alright, so now we can use these two things and that final bit of information that the sum of their marks is 110 to figure out what x has to be. So we know the sum of their marks, so that means it's going to be Jessica's score plus John's score. That's what the sum is going to be. So that'll be x for Jessica plus x plus 6, right? So over here we've got Jessica, and over here we've got John, right? So they're their two test scores, and we know that the sum of those is going to equal 110. Right, so if that's going to equal 110, now I don't really need to have these parentheses here, I don't need to have these brackets here. That's just because I had Jessica's score over here and this whole thing was John's score, but we're not multiplying John's score by anything, so I don't need to put those in brackets. If we were multiplying John's entire score by something, like multiplying it by 2 or whatever, then we would need to put brackets around this thing like we had, and then multiply it by whatever. But for this particular question, we don't need to do that. So let's add the two x's together. We've got x plus 6 equals 110. So x plus x, well, that's going to be 2x. And then if I don't want to have the 6 on this side, I'm going to subtract 6 from this side. I'll subtract 6 from that side. These ones will disappear. So I'll be left with 2x on the left, and 110 minus 6 is going to equal 104 on the right side. Right? So hopefully that's making sense. I hope I'm not going too quickly. So if 2x is equal to 104, then I can divide both sides by 2, and I'll be left with just x on the left side, so those 2's disappear from here. And on the right side, I'm going to get 104 divided by 2, which if you go ahead and do the math, should give you 52. Alright, so we should get 52 as our answer for x. Now, what is x in this case? We wanted to, and what did we want to find? Well, we wanted to find Jessica's test score and John's test score. Now we know Jessica's test score is represented by x, so that part is done. So we can write for our final answer up in this line. We know that since x is just Jessica's test score, we don't need to do anything else with this information for Jessica except to write down, therefore, Jess scored 52 marks or 52% or whatever. I'll say points because we don't know what it was out of, so maybe it wasn't 52%. So Jess scored 52 points on the test. But for John, we still need to do a little bit more work. I need to get rid of this line here. We know x is equal to 52, but John's score is equal to x plus 6, right? We said that in our second sort of let statement, even though it's not a let statement, but it's basically a let statement for what John's score is. X plus 6 is John's score. Now we know x is 52, so that means I can throw in a 52 for the x, and then we'll add 6 to that, and we get 58 for John's test score, right? So then we got, therefore Jess scored 52 points, and John scored 58 points, right? So we'll just finish off our therefore statement like that. So that would be the end of your therefore statement right there. So first we figured out what x was, and that gave us Jessica's test score, and then we used that information, plugged it back into this thing here to get John's test score, and then we finished it off with a sentence up there. So Jess scored 52 points and John scored 58 points. Now if you wanted to make sure that you've done it right, well, we can just go back and check. Is John's test score 6 higher than Jessica's? We just did the calculation to make sure that that was the case. 58 is indeed 6 points higher than 52. And the last thing that you could check is, does the total equal 110? So if you go and you do that addition, 8 plus 2 is 10, carry the 1, 5 plus 5 is 10 plus 1 is 11, so it does equal that 110 that we were given in the question, so we can be confident that this is indeed the correct answer. So that's just our little way to check our work. Alright, hopefully that's making sense, and hopefully I'm not going too fast, but I might need to speed up just a little bit for this third one. But this one's a slightly more complicated problem, just because it's using stuff that we haven't really talked about yet. But it is stuff that I expect you'll have seen before. So we'll go through this one decently quickly, this last one, but don't stress too much about something like this being on a test. If this is on a test and it's something that we haven't really discussed directly in class, like if it's if you need like a special formula for it, then I would give you the formula that you need. So for this third one, let's jump right into it. I apologize if it seems like I'm rushing at all. It's almost 11 o'clock, and I need to wrap this up relatively quickly because I got work in the morning. Yeah, so let's go through this one, and then if you guys have any questions, get in touch with me. But hopefully this isn't too quick. So, Paul wants to put a fence around his square garden. Alright, so Paul wants to put a fence around his square garden. The area of the garden is 25 square meters. Alright, so this is the part where we haven't really talked about area and perimeter and all that stuff. This is just an example for us to exercise some of our algebra skills. So, the area of the garden is 25 square meters. Find the total length of the fence. Alright, so I'll leave that up there while we just think about this. Now, we know if you've got a square garden like this, and let's call the side length, let's call it x for now. I was going to go with s or something, but s on the board looks a little bit like a 5 sometimes, so I'm going to steer clear of using something like s. That's the other thing with variables, is try to steer clear of names like I, because it can look like a 1, or a lowercase l could also look like a 1, s can look like a 5, o can look like a 0, small q can look like a 9 depending on how you write it, or depending on how you write your 9s. Some people's small g's look like 9s as well. But yeah, just steer clear of some of those letters. I used to write my lowercase z like this, but then I was finding that when I was writing quickly, it started to look a lot like my 2's, so I started putting lines through my z's. So if you're doing it with z, just make sure you can tell the difference between your 2's and your z's. I modified my z's so that I could tell the difference between the two. So let's call this side length x, because we don't have any letters or any numbers that look like x. So if we've got a side length of x here, and this is a square, that means all of these sides are going to be x. Now for the area of a square, this is the part that we haven't really talked about. For the area of the square, it's just going to be the length of the square times the width of the square, which in this case is just going to be x times x. So we get that the area of the square is going to be x squared, right? X times x. And the perimeter of the square, that is all the way around the outside, the sum of those side lengths is going to be x plus x plus x plus x. So that's 1, 2, 3, 4 x's added together, so I can say that the perimeter is 4 times x. So this is the part that we haven't really talked about with area and perimeter and that kind of stuff. So on a test, I would give you those two formulas as like a hint. I'd say hint x, or area of a square is length times width, or something like that. I'd give you something to sort of nudge you in the right direction, or I'll just give you the formulas outright. But I'll try and steer clear of questions that require such formulas. This is just for this example and to make it a little bit more complicated than the first two. So if we're using these two formulas, we have to ask ourselves, what does x actually represent? Because we came up with that. We didn't get that x from the question, so we still need to write a let statement for it. So we'll say, let x represent or equal or be, whatever, however you want to write it, let x represent, well, what is it here? We have a square. I mean, I know it looks like a rectangle, but we're pretending it's a square. Let x be, well, this distance right here is x, and that's basically just the side length of the square. So I'll just say let x represent the length of one side of the garden. Cool? Cool. Let x represent the length of one side of the garden. Now, we know the area was given to us, but if you wanted to put a fence around this garden, that means we need the perimeter. That means we're putting a fence basically exactly where I have the blue line drawn on the board here. So that'll be whatever x is, x plus x plus x plus x, that will be the perimeter. Now the problem is we don't even know what the length of one side is, but we know that once we get the length of one side, we can find the perimeter using this formula down here. And the perimeter is the amount of fence that we actually need in total. So we've got let x represent the length of one side of the garden, or if you're feeling lazy, you could say let x be the side length, whatever. Something that allows you to figure out what exactly we are dealing with here with our variable. So I'm going to get rid of the square down here. And I'm just going to copy out that first equation. So we know a is equal to x squared, right? The area is equal to x squared, but we know from the question that the area is 25 square meters. So that means this is an equation all on its own that we can use. X squared is equal to 25, which we can solve for x. I'm going to get rid of that area equation from down there now. So we know x squared is equal to 25, so that means x is going to just be the square root of that, right? If I take the square root of this side, I'll be left with just x, and if I take the square root of that side, I'll be left with one of two answers, right? The square root of 25 is 5, but we were talking in the last video how it could be positive 5 or negative 5, but since we're dealing with a real world scenario, if the length of a side of your garden is 5 meters, that makes sense. If the length of a side of your garden is negative 5 meters, that doesn't make any physical sense. You can't have something that's negative 5 meters long. So, in this case, because we're dealing with a real world scenario where a negative answer doesn't make sense, we're just going to write down that x is equal to 5. Alright, so it seems like a little bit of a, maybe not the ideal way to sort of go about it, because just last video we were talking about how there's two answers to the square root, but right now we're just looking at the two of them and we're realizing that one of them doesn't make any sense, so we just throw it in the garbage and we move right along. So then that tells us that we know what x is. Now with our let statement, we got that x is the length of one side of the garden, right? That's what we found based on our let statement. But that's not actually answering the question. We haven't made our variable, in this case, the same thing as what the question actually wants us to solve. The question wants the total length of the fence, which, for your garden, with a side length of 5, is you've got your square garden, so you've got 5, 5, 5, 5. Putting a fence just on one side doesn't mean putting a fence around the entire garden. So, for the fence going around the entire garden, that's going to equal the perimeter of the square, the sum total of all of those side lengths together. So we're going to use this formula here. P is equal to 4x. I'm going to get rid of it from down there. P is equal to 4x. And so P is the total amount of fencing that we need. You could put a separate let statement for let P be the total amount of fencing, or if you don't want P for perimeter, you could do T for total. That part's up to you. But the important part is that x equals 5 is not our final answer. The perimeter of the square is going to be our is going to be the number that we're looking for, and the perimeter is 4 times x, which is going to be 4 times 5. You could write it with a multiplication sign like that since we're just dealing with numbers, or you can write it like this, 4 and 5 like that in parentheses, which is going to equal 4 times 5 is 20 meters. And that would be the answer for how much fence you actually need, how much fencing you need to go and buy in order to enclose this garden. Alright, hopefully that makes sense. The last thing you could do here, of course, is go ahead and make that final therefore statement. So you say therefore, and then you can just answer it exactly the way it was worded in the question, just with your numbers. So we'll say therefore, the total length of the fence is 20 meters. And that's it. Alright, hopefully that makes a whole lot of sense, and if it makes anything less than that amount of sense, then, well, let me know and we can do some more practice. Either way, your next video lesson is gonna still be on this single variable algebra problem, so still working with just one variable. It might be more word problems, it might not. The next chance I'm gonna get to record, it'll already be like 9 o'clock in the evening before I get a chance to start. So depending on if I get a chance to make word problems throughout the day, you'll get word problems. Otherwise, we'll just go back to staring at the math and just solving for x. But either I'll make the questions more complicated ones where we're just dealing with the math itself, or I'll keep them relatively simple, but I'll keep the valuable information embedded in a word problem like what we had in this lesson. As always, if you guys have any questions, feel free to get in touch with me, and I will hopefully be able to respond to you very quickly, but my apologies if I don't. But yeah, if you have any questions, let me know. Otherwise, I will see you all in the next video. Have a good one.